Okay, we're going to do another example here of the generalized power rule. And in this case, maybe it's going to be a little bit tougher than the one we just did, because we're going to have to try a little bit harder to make it work. But well, before we get started here, let's just recap. The idea is we're going to make kind of a substitution here. We've got a really complicated integral with respect to x. It's kind of a big complicated function. And we want to convert it to a simpler integral with respect to a new variable, which we'll call u. Okay. So if you look at this, remember that this was written down in a different way in the book. U is something we choose, but du is something that's based on that choice, and du is just the derivative of u with respect to x times dx. Okay, that's something you need to input here. So the way we use this rule is we look at our integral and we say, okay, this is complicated. We don't know how to use this, to integrate this using a basic rule from the last section, 5.1. So could we perhaps take some of this rule, this function we're integrating, and call it u, and make this substitution to get a simpler integral with respect to u? Okay. So the choice is this. No one tells you, the problem is this, I should say, no one tells you what u should be. You have to just kind of figure it out for yourself, and you might even try a couple of different things. But generally, when you look at a function, if you're going to use this rule, make this substitution, you let u be the most complicated thing that's being raised to a power, or the most complicated thing that's inside of a square root or a root of some sort. So I would look at this and I would probably try to make u just 1 minus 2x squared, okay? Because that's kind of the biggest part of this expression that's being raised to a power. Okay, so I don't call the whole thing u, just the stuff inside that power. Okay. Now, once I choose u, I have to also figure out what du is. Okay, now remember, if you look at the rule in the book, they have one more statement here in the rule, and it's just basically to tell you that du is the derivative of u with respect to x times dx. Okay, so once I make that choice for u, I have to figure out what du is, okay, as a result. Okay, so du is going to be the derivative of u with respect to x. Okay, well, the derivative of this function is just going to be negative 4x, okay, times dx. Okay, so you're allowed to choose one thing. You're allowed to choose u. Du is going to be determined by that choice. Okay, so let's go back to the integral and see what we can make happen here. Okay, now I've got the integral of, and let me do one thing here. I kind of like the u stuff to be in front, so I'm going to write this as 1 minus 2x squared cubed times x dx. Okay, all I did here is I just move that x to the back side of the expression. I mean, we're just multiplying here, so I can multiply by the big parenthesis expression first, and then times x. Okay. Okay. So how did we do? Well, the hope is that we can replace all of this stuff with either u or du. Okay. And we're going to get really close. This is u to the power 3, right? U is 1 minus 2x squared, so that's u cubed. Okay. This is u here. Now here's the problem. Du is negative 4x dx. We don't have that. We have x dx. Okay, so we're not quite there. We don't have the right thing for du. We have something else inside our integral. Okay, but the important thing is this. Even though we don't have negative 4x dx, we're only off by a constant factor. Okay, we've got an x dx here. So I can do this little trick in math. If you multiply by negative 1/4 and then multiply again by negative 4, those two things cancel, right? Okay, so look what I did. I just did two things, really. I went inside this product and I multiplied by negative 4th, and to cancel that I multiplied by negative 4. Okay, so I did this basically to get the negative 4 where I needed it. Okay, you can always multiply by a constant as long as you multiply by the reciprocal somewhere else, okay, because those two things will cancel. So it's a little sneaky trick, but the negative 1/4 I can move right outside here. And then I've got the integral of u cubed. Okay, but look at this. That's exactly du. Okay, so I didn't have du to begin with, but I was really, really close. I was just off by a factor. Okay, so basically I multiplied by negative 4 and then divided by negative 4, which is the same thing as multiplying by negative 1/4. Okay, right next to it. Okay, so now I can make that exactly du. The negative 1/4 is still here, but that's just a constant. I can factor it out. Okay, so now I'm ready to go here. negative 1/4, and I have to integrate u cubed du using the power rule. It's just 1/4 u to the power 4. Okay. Right, that's all the generalized power rule really says after the substitution. You just integrate u like you would any other variable to a power. Okay, as long as we're integrating with respect to u. Okay. Okay, so this is going to be negative 1/16 u to the, whoops, I forgot my plus c, u to the power 4 plus c, and finally we got to convert everything back to x. U was, let's see, what was it? It was 1 minus 2x squared. So we get negative 1/16 times 1 minus 2x squared to the 4th power plus c. Okay, so that's our final answer.